here we're going to look at a real life kind of application problem. And this is kind of one of the nice, there's a whole bunch of different ones, but this is one of the nice applications of parabolas or quadratic equations. What's really nice about it is picture when you throw something, it follows a parabolic path, right? It goes up, kind of reaches some height, and then maybe falls down to the ground. And so it's nice because we can visualize it literally looks like what it represents. All right, so our question here is find all values for t which the ball's height is 13 meters. So they're telling you they want to know what different times would give you a height of 13 meters. So they're telling you height, you're definitely plugging that into your equation for h. So where there used to be an h, we're trying to see when is this equal to 13. Now a lot of times, notice you'll probably get two different answers, because say if just eyeballing, not to scale here, but say this is 13 meters. Notice it might hit that height on the way up or on the way down. So we might get more than one answer here, which a lot of times we do in quadratics, right? All right, so what can we try? We're trying to solve this. Well, no matter what we're going to try, we want it to be equal to 0, and usually I do like it if our terms are in order. So we have negative 5t squared plus 30t, and subtract 13 from both sides, so I get negative 10. So this doesn't look easy to factor. In fact, I can tell from the title of this section that it's going to be an irrational answer, means it doesn't factor nicely. So this would be a good one for quadratic formula. Now, it's equal to 0, so you can go straight into quadratic formula. Sometimes if you want to reduce the amount of simplifying you're going to have to do, if you notice there's something that all these are divisible by, that can also make your quadratic formula easier. And so I see really easily everything's divisible by 5, and maybe just to be even a little more proactive, I'll divide by negative 5, that way I won't have so many negative numbers to plug in. So I end up with t squared minus 6t, right, positive divided by a negative, and then plus 2, negative divided by a negative. And so this and this are equivalent, but notice for this one now, when I'm going to plug it into quadratic formula, a is 1, b is negative 6, and c is 2. And so let's write down our quadratic formula, except we'll leave blanks where all the numbers are going to go. That helps us with our order of operations. So it's negative b plus or minus square root of b squared minus 4ac all over 2a. All right, so everywhere there's a b, I'm going to put a negative 6. Everywhere there's an a, I'm going to put a 1, so 4ac and 2a. And everywhere there's a c, I'm going to put a 2. So now it's just a matter of simplifying as much as we can. So negatives cancel. I have 6 plus or minus the square root of 36 minus 8 all over 2. So 6 plus or minus square root of 36 minus 8 is 28 all over 2. Now if they were asking for exact answers, we'd want to see, hey, can I reduce square root of 28, all that kind of stuff. But here they want us to round to the nearest hundredth, so probably the most expedient thing to do would be, well, let's find out what is this number approximately. And picture that kind of makes sense, because if they want to know seconds, you don't want to tell someone it took 6 plus square root of 28 over 2 seconds for something to happen. You want to say, oh, about these many seconds. And I think they even tell you in the question to round to the nearest hundredth. So there's no reason I can't just go ahead and type what I have in here. You don't have to use the fraction menu. But it does make it a little easier sometimes to see what you're typing in. So it looks like one of them is about 5.65 seconds. So this was when I did the plus, so obviously there's two choices here. So 5.645, which rounds up to 6.5. So there's one answer for when I'll hit 13 meters. And then the other one is if I do 6 minus square root of 28 divided by 2, which gives me 0.35 seconds. So two different answers there for 2 times on the way up and then on the way down when it hit a height of 13 meters. So mainly you can tell these are all going to be decimal answers because it says in the title they're irrational. So a lot of using quadratic formula on this one.